Hi guys, we're going to learn about inscribed angles and inscribed quadrilaterals today. So we're going to start with just some notes. So the first thing is, what is an inscribed angle? An inscribed angle is an angle with its vertex on the circle with two of its sides that are chords. Sorry if you can hear my dog drinking in the background. She just thought now was the time to take a huge drink of water. So inscribed angle, this angle right here, angle ABC, is an inscribed angle because its vertex is on the edge of the circle and then its two sides are chords. Remember, the chords are the line segments that touch two sides of a circle. And then an intercepted arc is the arc that lies between the endpoints of the inscribed angle. So the intercepted arc for this one would be this arc AC, because that's the arc that lays in between those two chords, and it creates this angle as well. And then the degree of the inscribed angle is equal to half the measure of its intercepted arc. So if you look at this measure of angle ABC, that's your inscribed angle, it would be half of whatever this measure of arc AC is. So if I said this arc was 24, then this angle would be 12. So your inscribed angles are always half. If an inscribed angle intercepts a diameter, then it is a right angle. So if your inscribed angle right here has a diameter is where your two chords would intersect, then it creates a right angle because this arc is 180. So then half of that would be this inscribed angle. So that makes it 90 degrees. So if your chord goes through a diameter, your intercepted arc is a right angle. So this makes BAC 90 degrees. And then overlapping arcs, if two inscribed angles intercept the same arc. So if you look at this one, this angle ABD and angle DCA have the same intercepted arc AD right here. So if they have that, then that means these two angles are congruent. So that means that these two are the same measure and they would be half of whatever this measure AD is. Okay, so let's use that information to go through some of these problems. So let's start with number one here. It just says find the angle of each angle and arc measure. So for this one, it wants what is this angle down here, WXY? Well, we know that the intercepted arc is 62, so your inscribed angle is just half of that. So you would have 62 divided by 2, and you get that this is going to be 31 degrees. Okay, so over here, they want you to find the measure of arc DGF. So in this one, you have your inscribed angle as 113. So to go backwards and get this arc, you just do 113 times 2, which would make this arc 226 degrees. Okay, this one, you see that this is a diameter. So that means that the intercepted arc over here is 180 degrees. So that means this angle has to be half, and it's a 90-degree angle. So angle PQR is 90 degrees. Okay, in this one, they want you to find the arc of measure BC here. So this takes a little bit of extra steps. So the inscribed angle is ABC, this is 47. To get arc AC, which is your intercepted arc, you're just gonna do 47 times 2, and you'll get 94. And then I see that this is a semicircle. So if I want the measure of arc BC, then I'm just gonna do 180 minus 94, and I'll get that that's 86. So measure of arc BC is gonna be 86 degrees. Okay, this one wants the measure of angle JKL. So we want to know what that angle measure is right there. So they give us this little arc is 53, this little arc is 65. So then to get the rest of the circle, I can just subtract those from 360. So if I did 360 minus 53 minus 65, I'll get that that's 242 degrees. So this whole arc right here is 242. And then remember, the inscribed angle is half of that. So to get that angle, you're just going to divide by 2. So you'll get that that angle is 121 degrees. Okay, so we want to know RST, so this angle right here, and RUT. Now the first thing you should notice is that they have the same intercepted arc, because the chord that creates angle S right here is these two chords, and then these two chords create the angle U, and then they intercept the same arc. So what that means is these two angles are the same. So once I find one, I know what the other ones are. And then again, it's that same process. So I know this arc is 64, this is 139, this is 75. So to get what arc RT is, I can just subtract all of them from 360. So if I do 360 minus 64 minus 75 minus 139, I'll get that is 82 degrees. So this arc right here is 82. And then remember that the inscribed angles are half. So if I just take 82 divided by 2, I get each of these are 41 degrees. Cool. So now we're going to just do a little bit more algebra when we do these. So it says find each measure So in this one, it wants us to solve for x. So this is setting up a formula. So this is your intercepted arc, and this is your inscribed angle. So you just have to remember the relationship. This inscribed angle is half of this. So if I take 158 and divide it by 2, that should equal my 8x minus 9. So if I do 158 divided by 2, let's see, I solved this differently the first time. So 158 divided by 2 would be 79, is equal to 8x plus 9, add 9 to both, oops, minus 9, add 9 to both sides, 88 equals 8x, so then that means x has to equal 11 for this one. So still using the formula, you just now have some algebra going with it. Okay, this one we're just gonna set up and not solve all the way. So you have this arc and this inscribed angle. So remember, this is half of this one. So a way to do this is I can do 2 times 67. If I double that inscribed angle, it should equal this 4x plus 58. And then you would just multiply and then do some algebra. And then at the end, I think this one becomes x is equal to 19 if you want to do it and check. Okay, number 9. So let's see here. We know that this is a diameter, so that means this inscribed arc over here is 180 degrees. So that means that this angle is 90. So if I want to solve for x, I'm just going to take 3x minus 1, or 13x minus 1. I'm going to set it equal to 90. So 13x equals 91, divide by 13, you'll get x is 7 for this one. So just remember, if it goes through a diameter, inscribed angle is going to be 90 degrees, or half of that 180. Okay, 10 over here, solve for x. So let's see, the first thing I can see is that you have this inscribed arc goes with this angle. So if I take 78 divided by 2, I'll get that this angle is 39. And then I can do triangle angle sum theorem here. So if I do 180 minus 114 minus 39, I'll get whatever this angle should be. So 180 minus 114 minus 39, this becomes 27. So then I can just take this 7x plus 6 and make it equal 27. Subtract 6 from both sides, be 21. So then x has to equal 3 for this one. Awesome. 11, we're just going to set up and not solve all the way. So let's see. You have this arc is 92, this is 162. So I can get the measure of AC by doing 360 minus 162 minus 92. And that would be 106 degrees. And then remember, this inscribed angle is half of that. So I can do 106 divided by 2 is equal to 7x minus 10. And then I can just solve down for x. And I think this one becomes x is 9 if you want to keep going. Okay, 12. Let's see what I did here. Okay, so we know this inscribed angle is 67. So I can find this arc by doing 2 times 67 because it's double. So if I do that, that's 134 degrees. And then I can figure out what this arc has to be because we now have our full circle. So if I did 360 minus 120 minus 134, I would get that that is 106. So this arc is 106. And then you would just do 5x plus 21 equals 106. Do your algebra, and you guys should get this as x is 17. So subtract 21, divide by 5. Sweet. Okay, 13. Find the measure of FGH. We're trying to find this. Oh, nope, just kidding. That is this. And then the arc FJH is this. Find the measure of arc FJH. Okay, so the relationship is that the blue arc is double what this one is. So I can take my purple, my angle 2, and double it. So 2 times 6x plus 21, and I know that's going to now equal what my arc was. So let's see. Distribute 12x plus 42 equals 17x minus 28. Add. So what, 70 equals 5x, so then x is going to be 14. And then this is the mean one. It wants you to find that arc. So just plug it back in. Measure of FJH is equal to 17 times 14 minus 28, which you plug that in your calculator. It's going to be 210 degrees. Okay, we're gonna skip 14. 15, it says the measure of angle ABD is that, and the measure of ACD is this, and they want you to find the measure of arc AD. So what you should notice is they're both inscribed angles. They share the same intercepted arc. That means that they are going to be equal to each other. So you're going to solve this, making this angle equal to this angle. And then do some algebra. So let's see, add 9 minus 6x. So x is 5, and then they want you to find the measure of arc AD. So then if I plug it back into one of these angles, so let's say measure of angle ABD is 6 times 5 plus 26, so 30 plus 26 is 56. And then I know my arc is going to be double that. So to get the measure of arc AD, you just do 2 times 56, and you'll get that to be 112 degrees. Cool, last one, and then I'll make a short little video of doing the inscribed quadrilaterals for you guys. So last one here says measure of KJL. So that angle is this, and KLJ is this. Find the measure of KL. Okay, so first thing you guys should realize is this is a diameter. So this intercepted arc is 180. That means this angle is 90 degrees. And so we know that all 3 of these have to add up to be a total of 180. So if I do 3x plus 2 plus 7x minus 32 plus 90, that'll be 180. So let's see, 10x minus 30 is equal to 90. We just subtract this over here and combine like terms. So then 10x is equal to 120. So x is going to be 12. And then we want to find the measure of KL. So let's see, if I want this arc, I want to know this angle. So let's plug it into this formula. So we'll get the measure of angle KJL is 3 times 12 plus 2, which is 38 degrees. So my inscribed angle right here is 38. So to get the measure of arc KL, we just double it. So 2 times 38, we'll get that that is 76 degrees. So a lot of doing the same formulas. The big thing you should just remember is that your intercepted arc is double whatever your inscribed angle is. And then again, if you have an intersection that goes through the diameter, the inscribed angle is going to be 90 degrees. Awesome. Make sure you watch the next really, really short video explaining how you guys are going to do inscribed angles whenever you have a quadrilateral that's inscribed. And then you guys are going to do the homework. Just make sure you pay really close attention to the problems I want you guys to do, because it's not going to be all of them.